We're doing some more arithmetic with square root functions, and they're just shortcuts that I could highlight, I could put stars next to. We're going to be using them over and over again. I'm just going to underline them because these first two are equivalent. We could rewrite square roots as products and just merge them together. Quotients, that's division, we can just separate them. But that only works for multiplication and division. Addition and subtraction is not equal to. So don't fall into that trap. So what we're practicing here is what's called simplest radical form. And there's kind of a long way to do this. There's a short way, but then there's a way that a lot of math teachers teach. And that's through the use of factor trees. For instance, we could break up 48 as 2 times 24. And we can break up 24 as 2 and 12. We can break up 12 as 2 and 6. And we can break up 6 as 2 and 3. And what I'm trying to get at here is we want square roots. And the whole thought process is by doing factor trees with prime numbers is 2 times 2 is 4. And I know the square root of 4 is 2. Same thing with this, 2 times 2. That's 4, and we can do the square root of 4 is 2. And we don't know the square root of 3, so we just leave it like that. The theme is that pairs of numbers, right, kind of underline this, pairs of numbers can be combined together as a single number, but our final answer is I want you to actually multiply that together. It's 4 root 3. Some other teachers, they might explain it a little bit differently, but the whole theme is that you are rewriting root 48 as root 4 times root 4 times root 3. And so from there, we know the square root of 4 is 2, the square root of 4 is 2, and we get the right answer. You can also check your work with a calculator. I don't know the square root of 48. Second square root 48. But the answer I come up with, 4 root 3, should be equal, the same decimal to what we started with. So that's a way you can check your work. Now here's the thing, is some people might say, what if I find a pair of numbers faster? I would say, well then go ahead. Because you might look at this and say 2 and 100, and then from there you can say, okay, well I know 100 is 10 times 10. That's a pair of numbers. So you could just combine them together to be 10 root 2. Non-pairs at the bottom of the tree stay under the radical. If anybody's sitting there and saying, I don't like that, I want to go ahead and break this down again as 5 and 2 and 5 and 2. Well, if you have a pair of 2s, that would be 2. And then a pair of 5s would be 5. And then you don't have a pair for that 2. Look at that, it's the same answer. So what if we make it a little bit more complicated? Okay, we'll break this down. We have 2 and 9. 3 and 3. Pairs go in front, but don't forget about that 5 that was in front as well. We don't have a pair for that 2, so it stays under the radical. But the final answer would be 15 because it's 5 times 3, root 2. That's the answer I want. And we can also do things with square roots. Who cares that we have this divided by 2? If I ask you to break down 72, maybe you do this as 2 and 36, and then you see 6 and 6. All right, well, there's your pair of numbers. So you could rewrite this as 6 root 2 over 2. But we could simplify that further because 6 divided by 2 is 3. Now be careful. You can only divide whole numbers with whole numbers. So you're not doing the root 2 divided by 2. That would be wrong. And again, you can check that you have the right answer because if I make this as a root 72 over 2, it'll give me a decimal. But what I'm saying is that's equal to the same thing as 3 root 2. And look at that, we have the right answer. And then we could also FOIL these types of problems. So if I look at the next one, we have root 12 times root 3. Okay, well 12 times 3 is 36 and it stays under the radical. Then the outside term cannot multiply whole numbers with radicals. The inside term, you cannot do whole numbers with radicals. And then negative 4 times 3 is negative 12. But you're not done because I know the square root of 36 is 6. And we can combine that 6 with this negative 12 over here, so I know it's going to be negative 6. If you look at your answers, that's the only correct answer. Now, I don't want you just to assume that that's the right answer. Go ahead and practice breaking down 12. Okay, well, we have 3 and 4, 2 and 2. So that's a pair of 2's to bring in front with this 3. So that would be 6 root 3, because it's 3 times 2 with this 3 staying under the radical, minus 4 root 3. Well, we can combine like terms. Just think of this as 6x minus 4x is 2x. So 6 root 3 minus 4 root 3 is also 2 root 3. So I confirm that option 1 was correct. And at any point, feel free to pause the video or re-watch it, or try problems on your own. That would be totally fine. Because if I look at the next one, remember to square a binomial. That's what this is. You have to multiply by itself. And maybe I didn't explain this good enough earlier. You have to FOIL it out. So root 8 times root 8, well, that's root 64. Root 8 times negative 2, that's negative 2 root 8. Inside is negative 2 root 8 as well, and negative 2 times negative 2 is positive 4. But we're not done, because we know the square root of 64 is 8. If you didn't know that, then you should practice a few rules. And then 8 plus this 4 over here would give me 12. You can probably figure out what the right answer is. But let's confirm that we have the right answer, because we can break down 8 as 4 and 2, and 2 and 2. So we have a pair of 2's that we can bring in front to multiply by this 2. So what we have is negative 4 root 2. And the same work would really be done here. 4 and 2, 2 and 2. So you'd have a pair of 2's to multiply about that. If you're curious where the other root 2 comes from, it's because we had a number that did not have a pair. So we're left with negative 4. You can think of it as negative 4x minus 4x is negative 8x. So yeah, we confirmed that option 2 was the correct answer. So what we'll also be doing is, I guess we're just making it a little bit more complicated, but it doesn't look that much more difficult. But we're practicing simplifying and combining like terms. And maybe this will be where I explain a little bit more detail. But practice the same thing I've already talked about. If you like my explanation of pairs of numbers go in front, and the non-pairs stay under the radical. Go with that. Maybe I'll change colors. That we have 25 times 3. And 5 breaks down as 5. There's your pair. And the whole thought process, like I've said earlier, is you can think of this as like 3x plus 5x is equal to 8x. That's what's happening here. 3 root 3 plus 5 root 3 is equal to 8 root 3. And again, you can use your calculator to check your work. Root 27 plus, whoops, got to hit the arrow over to get out of that, plus root 75 gives you a decimal, and what I'm saying is that's equal to 8 root 3. It's the same decimal, so I did it correctly. A little bit more complicated on this next one. 25 times 2, but again we have 5 times 5, so we're looking at 5 root 2. The next one, just to give you a different color, you can break down that 8. 4 and 2, 2 and 2. But remember, you have to multiply by that 7 in front, so it becomes 14 root 2. And 162 is a little bit more daunting, but it is 81 times 2, and I know 81 is 9 times 9. That, when I multiply that in front, what I would actually do is do 9 divided by 3 first, which is 3 times that 2 would give me 6 root 2. But from there, 5 plus 14 is 19, plus 6 would be 25 root 2. Feel free to pause the video and double check that all of that made sense. As a reminder, we could also do things involving the Pythagorean theorem, and which you may have learned, I hope you learned, but a squared plus b squared is equal to c squared. And the c is the hypotenuse. That is the angle that is across. Sorry, that's the side that is across from the right angle. So if I'm asking you for the hypotenuse, you want to practice doing a leg squared. I guess I should emphasize that A is a leg and B is a leg. That's what we call the sides that are adjacent to the right angles. That means next to. So if you're solving this problem, it would be root 18 squared plus root 32 squared. Well, the square root and the squares, I think we've learned already, cancel each other out, is equal to the hypotenuse squared. So 18 plus 32 gives me 50. And to solve a square problem, we have to square root. So in simplest radical form, the hypotenuse, you have to break it down, 25 times 2. 25 breaks down as 5 and 5. I feel like we've done this problem a lot, breaking down the root 50. But simplest radical form will give you 5 root 2. So from here, we can actually find the perimeter. Let's go back to that root 18. Okay, well, root 18 we could break as 9 and 2, and then 3 and 3. So we have 3 root 2. Let's talk about root 32 as well. Now, 32 you could break down as 16 times 2, and then 4 and 4. So we're looking at 4 root 2. And then don't forget that we want the perimeter as all the side lengths. So we also have that 5 root 2. So 3 plus 4 is 7, plus this 5 would give me 12 root 2 is the answer we're looking for there. And then the very last problem, pretty complicated stuff, but be strategic about this. I would suggest ignoring the squared on the outside, and I hope you notice that inside what we end up with is what we call conjugates. Why is that important? Because as you start to FOIL this out and you get 4, the outside is 2 root 3, the inside is negative 2 root 3, and I hope you notice that those things cancel. And then on the other piece, root 3 times root 3 would be root 9, but as we look at that, the square root of 9, we know that is 3, and 4 minus 3 is 1, and now let's square it. Well, 1 squared equals 1. Pretty straightforward stuff if you're strategic about how you do the problem. So hopefully I didn't go too fast. I feel like you've learned this before. That's why it's called a review. But if you haven't learned it, now is a good time to figure it out to do your homework.